Hello! Today we're going to explore a fascinating pattern involving the imaginary unit, I. By the end of this video, you will be able to determine the value of I raised to any positive integer power, men. This means you'll be able to figure out if I to the power of n is equal to 1, -1, I, or negative I. Let's begin by recalling the fundamental definition of the imaginary unit. The imaginary unit, I, is defined as the square root of -1. This is a number that, when squared, gives you -1. So, by definition, I squared is equal to -1. This is the most important fact we'll use today. Now let's see what happens when we raise I to higher and higher powers. We'll start with the first few. Let's begin our exploration of the powers of I. First, any number raised to the power of 1 is just itself, so I to the power of 1 is simply I. Next we have I squared. As we just recalled, the definition of I is that I squared equals -1. So I squared is equal to -1. Now let's find I cubed. We can write I cubed as I squared times I. We know that I squared is -1, so we can substitute that in. This gives us -1 times I, which simplifies to -I. Finally, let's look at I to the 4th power. We can write this as I squared times I squared. Since I squared is -1, we have -1 times -1, which equals +1. Let's summarize what we found so far. We have I to the 1st is I squared is -1, I cubed is negative, I, and I to the 4th is 1. Now, what do you think will happen with I to the 5th power? Let's find out. Let's continue our pattern and see what happens with I to the 5th power. We can write I to the 5th as I to the 4th times I. From our previous calculations, we know that I to the 4th power is equal to 1. So we can substitute 1 for I to the 4th. This gives us 1 times I, which is just I. Notice something interesting here. I to the 5th is equal to I to the 1st. The pattern has started to repeat. Let's see if this pattern continues. What about I to the 6th? I to the 6th is I to the 4th times I squared. That's 1 times -1, which is -1. This is the same as I squared. And A to the 7th is I to the 4th times I cubed. That's 1 times -I, which is -I z-sat. This is the same as I cubed. Finally, I to the 8th is I to the 4th times I to the 4th. That's 1 times 1, which is 1. This is the same as I to the 4th. We have confirmed that the pattern of powers of I repeats every 4 terms. The sequence is I -1, I 1, and then it starts all over again. This 4-term cycle is the key to solving any power of I. So how can we use this 4-term cycle to find the value of I to any power 10? The trick is to figure out where in the cycle the power n lands. We can do this using division. We'll take the exponent, n, and divide it by 4. The remainder from this division will tell us the answer. Let's look at the possible remainders when you divide a number by 4. The remainder can be 0, 1, 2, or 3. It can't be 4 or higher, because if it were, you could divide by 4 again. Each of these remainders corresponds to one of the 4 values in our cycle. If the remainder is 1, the answer is I, or if the remainder is 2, the answer is -1. If the remainder is 3, the answer is -I, and if the remainder is 0, the answer is 1. Let's try an example to see this in action. Let's find the value of I to the power of 23. First, we divide the exponent, 23, by 4. 23 divided by 4 is 5, with a remainder of 3. This means that 23 is 5 full cycles of 4, plus 3 more steps. The remainder is 3. Looking at our rule, a remainder of 3 means the answer is negative, I. Therefore, I to the power of 23 is equal to negative I. Let's do one more example. What is I to the power of 100? We divide 100 by 4. 100 divided by 4 is exactly 25, with a remainder of 0. This means 100 is 25 full cycles. A remainder of 0 corresponds to the fourth term in the cycle, which is 1. So I to the power of 100 is equal to 1. Let's recap what we've learned today. We started with the definition of the imaginary unit, I, as the square root of negative 1. This means that I squared is equal to negative 1. By calculating the first few powers of I, we discovered a repeating pattern. The powers of I cycle through the values I, negative 1, negative I, and 1. This cycle has a length of 4. To find the value of I to any positive integer power, n, we use the remainder when n is divided by 4. If the remainder is 1, the answer is I Yuri. If it's 2, the answer is negative 1. If it's 3, the answer is negative I Ofo. And if the remainder is 0, the answer is 1. This simple rule allows you to quickly determine the value of I raised to any power. You have now met our learning objective for today. Thank you for watching.